This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 3, HVAC System Types, starting with the single duct constant volume system with reheat. This one is concept and diagram, no formula. One central air handler pushes a fixed volume of cold air down a single duct, and at each zone a reheat coil, driven by a space thermostat, adds heat back to hit that zone's set point. We'll read the schematic, frame it against the central component train, and pin down the trade it makes. Excellent temperature and humidity control, bought with a part load energy penalty. Concept 1. Read the schematic. A single air handler on the left conditions all the air to one cold supply temperature, around 55 degrees, and pushes a constant volume down one duct. Each zone taps that duct through its own reheat coil, shown in orange, and the zone thermostat, marked T, modulates that coil up as the zone's load drops. Notice the two things that define this system. The airflow is fixed, the fan never changes CFM, and the zone temperature is trimmed by reheat, not by airflow. Framing, the central component train. The cold duct doesn't come from nowhere. Behind it is a standard central air handler. In airflow order, a return fan with relief dampers, then the mixed air section, where outdoor, return, and exhaust dampers set the outdoor air fraction and enable the economizer. Then pre- and final filters, then the heating and cooling coils that condition the air, a humidifier for winter, and the supply fan that delivers the constant volume. One distinction worth knowing: draw-through puts the fan after the coils, so its motor heat lands in the cold supply air. Blow-through puts the fan ahead of the coils. How it works. Trim by reheat, pay at part load. The fan always moves the same CFM. When a zone needs less cooling, the system does not throttle the air. Instead, the thermostat opens the reheat coil and warms that cold supply air back up until the zone holds set point. That's the whole trade. The upside: steady airflow gives very tight temperature and humidity control, which is why you see it in labs, hospitals, and clean spaces. The downside: at part load you cool the air and then heat it again, paying for both, which is exactly why energy codes limit this simultaneous heating and cooling. And be clear, the reheat coil adds heat to already cooled air. It's active heating, not less cooling. How the exam tests this. There's no arithmetic. It's a system identification question. What they want is the discrimination against VAV, so hold the pair side by side. Constant volume reheat keeps airflow fixed and trims each zone with a reheat coil. VAV keeps the supply cold and varies the airflow with a damper. Constant volume reheat has poor part load energy because it cools then reheats. VAV is good at part load because it just throttles the air. Constant volume reheat suits tight temperature and humidity spaces. VAV suits typical offices. If a prompt gives you fixed airflow plus a zone reheat coil, that's constant volume reheat. Traps: 5 ways this bites. 1. It's constant volume, variable temperature, the mirror image of VAV, which is variable volume, fixed supply temp. Swapping them is the classic mislabel. 2. Reheat wastes energy at part load because you cool all the air and then heat it back up, paying twice, which is why codes restrict simultaneous heating and cooling. 3. The reheat coil adds heat. It's active heating, not less cooling. 4. There's one cold supply temp for every zone, so the per-zone reheat coil is what makes different set points possible. 5. The load and airflow math isn't here. It comes from the Week 4 airside and Week 2 load methods. This lesson is the system concept, not the arithmetic. Quick recall: single duct constant volume reheat is one air handler delivering a fixed volume of cold air, with each zone's reheat coil modulated by a space thermostat. It's built on the standard central component train, mixed air section, coils, fan. The signature: constant volume, variable temperature, the opposite of VAV. And its weakness is the part load penalty. You cool then reheat, which is why codes limit reheat. Golden rule: fixed volume, temperature trimmed by reheat, buying tight control at the cost of part load energy. For the thermostat control loop itself, see Week 6, Lesson 2. Next up, Lesson 4, VAV and multi-zone. Constant volume reheat, fix the airflow and trim the temperature. The VAV family does the reverse. We'll cover single duct VAV, the terminal that varies airflow on the space thermostat, while the supply stays cold. Plus its dual maximum and series versus parallel fan-powered variants, and the multi-zone concept. Everything's at PEPrepEngine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.